Hi everyone. In this video, we're going to be going over 4.7, which is polynomial and rational inequalities. So for a polynomial function, we need to know the end behavior and the x-intercepts and their multiplicity in order to help us solve an inequality. So let's look at this one. We have x plus 2 squared times x minus 5 is greater than or equal to 0. There's a few ways that I could start to solve this. Your graphing calculator is going to be a really helpful tool for this section. Graphing the function and looking at what's going on the graph is going to tell us kind of where the function is greater than or equal to 0. So we're going to graph not in Desmos, we're going to graph on our graphing calculator. X plus 2 squared times x minus 5. So I'm going to switch over my screen to graph that. So we're going to clear this out. We're going to put in our function x plus 2 squared, and then times x minus 5, and graph. We're looking for where this function is greater than or equal to 0. We can see that happens at a couple of points. Right here, let me zoom in. Right here at x equals -2, the function is equal to 0. And then here is at 1, 2, 3, 4, 5. Everything above from 5 and beyond is greater than 0. So I could write my solution. We have one part of our solution at x equals -2. The other part of our solution is everything greater than or equal to -5, or sorry, +5. So if I were going to write that in inequality notation, I would say either x equals 2, sorry, not 2, I keep saying that, x equals -2, or x is greater than or equal to +5. In interval notation, x equals -2 would just be bracket -2 to -2. And then we do a union. X is greater than or equal to 5. That equal to gets a bracket from 5 to infinity. And that is our solution. We could also try to do this algebraically by picking test points on either side of the zeros, just like we did for quadratic functions. But this is much easier to do using a graphing calculator. So that is the method that we're going to be using. Okay. This is just a picture of the graph that we just saw. And let's do another one. All right, next we're going to look at x cubed less than 3x squared. And to do these inequalities with polynomials like this, we're going to start by just always getting one side equal to 0. So instead of looking at this as x cubed is less than 3x squared, we're going to subtract the 3x squared over and look at x cubed minus 3x squared is less than 0. Notice this time it's less than, not less than or equal to. So if it's equal to 0, it's not a solution, only if it's below 0 this time. Okay, so we're again going to switch over and graph x cubed minus 3x squared. So x cubed minus 3x squared. Whoops, I put that all in the... Okay, I'm going to clear it all out. I did that wrong. Okay, x cubed, and then I need to come out of the exponent by cursoring over, and then minus 3x squared. There we go. We're going to graph. And I can see here my function goes from negative infinity up to 0 right in the middle, where it touches 0, so that is not a solution, right? That one point right there skips the solution. And then it's below 0 again, up to 1, 2, 3. And then from 3 on, it's greater than 0. So our solution is going to be everything from negative infinity up to 0. Since 0 is not a solution, we skip that point. And then everything between 0 and 3. And then nothing else is a solution because we're just looking at less than. Okay, so let's look at how we would write that as our answer. Okay, so it's everything from negative infinity up to 0. At 0, the function's equal to 0, but we don't want that, right? We only want less than. We're going to skip 0. This is our notation to skip 0. Then we went from 0 to 1, 2, 3. Again, at 3, the function is equal to 0, but we don't want that. So we use a parentheses to say 3 is not actually included in our solution. So this is pretty much saying everything from negative infinity to 3, skipping 0. All right, let's do another one. So this time we have x plus 5 squared over x squared minus 4. We're going to just go ahead and start by graphing. So I'm going to put parentheses around numerator and denominator. So we're going to do parentheses x plus 5 squared, and then divide parentheses x squared minus 4. And graph. So we're looking for where this function is less than 0. And it's a little bit tricky to tell here. So we're going to kind of start by analyzing our graph, and then we'll look at kind of where the asymptotes would be here. So if we look at our graph, it's a little bit hard to see. This is negative 1, 2, 3, 4, 5. So we have an x-intercept right here at negative 5. Everything else is above 0. So this one is less than or equal to, so that means where the graph touches the x-axis is part of our solution. That means right here, -5 is part of our solution. And I have an asymptote here at -2 and another asymptote over here at +2. I can also get that by factoring the denominator. Everything between those two asymptotes at -2 and +2 is below 0. So I have a solution at -5, and then everything between -2 and +2. So I will show you guys how I would write that. Right. So that is right down here. We have a solution at -5, and then between -2 and +2. If we can't necessarily see where those asymptotes were on our graph, we could also get that by setting the denominator equal to 0, right? Where I have 1 at x equals -2, 1 at x equals +2. And then the function doesn't actually touch the asymptote, so we're using parentheses, but it's going to get really, really close. So brackets around -5 because it is included, parentheses from -2 to 2. Right, and that is it. This one was a really short section. Again, make sure you read your textbook for this section. Look at those examples as well. It will be really helpful. And as always, make sure you do your homework. Send me any questions that you have. Let me know if you want to meet separately to go over anything. Okay, and that's it.